Okay, this is going to be a video on graphing step functions. This is for pre-calculus, the step function concept, step function or greatest integer. Okay, so here's the idea. Let's just use, okay, let's use a person. Do this in class. Okay, if I had a little table, we're going to make this. If I'm at a table, the greatest integer, if I'm at 1 is 1. Okay, now if I start walking, that person starts walking, let's say he gets there, which should be like 1.5. The greatest integer that he's reached is still 1. Even if it's 1.9, the greatest integer is 1. When does it get to 2? When he's at 2. Then like 2.5 would be 2. 2.9 would be 2. And then once he gets to 3, then it's 3. And then so on. Okay? All right? So what would that look like on a graph? All right? 1 over 1 up would be a dot. Okay? Let's say 1.5 over, 1 up. 1.9 over, 1 up. When it gets to 2, it's 2 over, 2 up. 2.5 over, there. 2.9 there. Then it's at 3. Oops, sorry. Okay, at 1, 1.5, and then 2, and then 2.5, okay, then at 3, it's up here. Now, if you were to draw these lines, what you do is you draw here, open circle. Draw here, open circle. Draw here, open circle. Okay, you draw a line, a thing like this, and then an open circle. That's the way it always goes. Okay, so that's the concept of the greatest integer. Okay. Now, from a graphing standpoint, of a lot of what we've learned, let's say I've got x plus 3 minus 5. All right, here's the concept. Greatest integer, 0, 1, 2, negative 1, negative 2. Greatest integer of 0 is 0, 1 is 1, 2 is 2, negative 1, negative 2. Okay, same deal, solve the inside. So x equals negative 3. That changes that. Do my interval. 1 divided by the number in front of x, which happens to be 1. So my interval is 1. So that's negative 2. That's negative 1. That's negative 4. That's negative 5. Okay? Adjust the y values. I would just subtract 5. So that's negative 7, negative 6, negative 5, negative 4, negative 3. Okay? And I'm going to plot negative 5 over, negative 7 down, which would be right here. Negative 4 over, negative 6 down, which would be here. Negative 3 over, negative 5 down, which would be here. Negative 2 over, negative 4 down, which would be here. Negative 1 over, negative 3 down, which would be here. So what I want to do is I want to draw there, open circle, there, open circle, there, open circle, there, open circle, there, open circle. Okay, and that's the step function. Okay, let me see if I can blow this graph up a little bit, because I think I'm going to need to graph the halves. Okay, that's good. That's good. All right. Okay, let's do another one. Let's say I got y equals 2 x minus 3. Okay. All right. Plus 1. No, that's not 2 minus 2. That's 2 minus 4. Just so we're not using the same relative number. All right. So what I would do, step function, 0, 1, 2, negative 1, negative 2. That's 0, 1, 2, negative 1, negative 2. What I would do is I would solve for what's inside, which that's going to be 4. So that's now going to be 4. Okay. Then I got 1 divided by the number in front of x, which is 1. It's going to be 5 and 6. 3 and 2. I'm going to multiply by 2 and add 1. So that's negative 2 times 2 would be negative 4, plus 1 would be negative 3. Negative 2 plus 1 will be negative 1. This would be 1. This would be 2, 3, 4, 5. Okay? So at 2, negative 3, 2 over -3 down. Okay, 3 over -1 down. 4 over 1 up. 5 over 3 up. 6 over 5 up. Once again, I'm drawn to this. Draw to the next one. There's a step function without. Let's do 2 more. Let's say I got y equals -3x plus 7. Okay? So same start. Okay, solve for thin side, still 0. Okay, interval, 1 divided by 1 is 1. So that's going to be 1, 2, -1, -2. Okay, now what am I going to do? Times by -3, add 7. So that's going to be 6 plus 7 will be 13. Okay, all right. That would be 4, 11, 0, and 7, -3, and 4, -6, and 1. Okay. Now this goes off the grid a little bit. -2, 13. Let's say 11, 12, 13. Okay. At -11, -1, positive 11. Okay. Okay. Hold on, that's 6. Yeah, that's right. No way that math is getting me. All right, 0 over 7 up. What's wrong with this? That's 3, that should be 10, sorry. That's why that's a little bit crazy, sorry. Yeah. I was wondering why. All right, and then 1 over 4 up. And then 2 over 1 up. Once again, I'm drawing until I get to the next one, and I'm putting an open circle. Open, open, open. So regardless of how the integer plays out, that's what you do. Okay, all right? Let's do one more. Okay? Let me spread this out a little bit. Especially more so the width-wise. Okay, let's say I have y equals, say 2 minus 4 plus 3. All right, so it would start out the same way. -2, -2, -1, -1, 0, 1, 0, 0, 1, 1, 2, 2. Okay, so if I solve the inside, 2x minus 4 equals 0. That'd be x equals 2 as a solution, so 2. Now, when you get to the interval though, I gotta divide 1 by the number in front of x, which is its back, so it's a half. So this is gonna be 2.5, this would be 3, this would be 1.5, and this would be 1, okay? I add 3 to all these values, so it's 1, 2, 3, 4, 5. So 1 over, 1 up. Okay, 1.5 over, 2 up. Okay, 2 over 3 up. 2.5 over 4 up. And then 3 over 5 up. So what I want to do, draw till I get to here underneath, here underneath, here underneath, here underneath, and they're moving in half increments. So it's sort of shrunk the size of the step. Okay, so here are some ones that you probably want to work on your own. Okay, go ahead and try those 3-step functions on your own.